Yes, at this juncture, we want to look at calculus. Okay, this is a Form 4 topic, and the topic is very, very important when it comes to examination. It is actually frequently being examined, and through the papers that have been done for the last, I can say, four years. For the last 4 years, the topic has been intensively set. So this topic is very, very important. So we are going to go through this topic with our concern areas, that is turning point, determining maximum, minimum, or point of inflection, and also curve sketching. So it means in that case you will be given an equation of a curve, just for instance like the one we have on the board, like this. You can be told to use the equation of a curve like the one we have, determine the turning point, then maybe the next question, determine whether the points you have found out are maximum or minimum, or even the point of inflection. Then lastly, you can be asked, now sketch the curve. So here we begin. So in this case, first of all, when the question presents itself in this manner, like we have this bracket multiplying that bracket. So we first of all open the bracket first. So doing that, this is what we do. We are going to have this multiplying the whole bracket, then these three again also will multiply the whole bracket. So it means therefore I will have x multiplying the whole bracket, then I come to -3, again multiplying the whole bracket. So therefore you will have 2x power 3, 3x squared plus x minus 6x squared minus 9x just a minute. -3 times this gives you this. -3 times -3x gives you +9. Then -3 times +1 gives you -3. So this is what we have. This times that gives you this, -3 times 2x squared gives you this, gives you a +9x, gives you a -3. So it means therefore you will have, let's collect the like terms together. Here we have 2x squared, then we have this and that, -3x squared, -6x squared, that is -9x squared. I have x plus 9x, that one gives you 10x. This is cube. Then I have -3. So when I open the bracket, then I will end up with 2x cubed minus 9x squared plus 10x minus 3. So this is our equation of a curve. This is equation of a curve. So we want to answer the three areas that we have listed. That is turning point, determining whether the point is maximum, minimum, or point of inflection. Then finally, you sketch the curve. So therefore, we proceed. So we proceed, and this is our equation of the curve. Equation of the curve. Then we are going to get differentiation, that is dy dx. And this is the general formula for differentiation. Generally, if we have equation of a curve in this form, x raised to n. So generally, the differentiation in this form of an expression, it is normally dy dx. And this gives you whatever we have as the power normally multiplies everything. So it means I will have this n multiplies everything, multiplies the whole term. Then I will have x, but now its power is reduced by 1. The power is reduced by 1. So this is actually a general formula for differentiation, and it is what we want to apply in this case. So let's apply that formula. So here we begin. We are saying when we start with 2x power 3, then we are saying this power 3 multiplies the whole term. It means therefore I will have 3 multiplying 2. So that it means it will be 6. Then I will have x, then the power of x is reduced by 1. I will come and subtract 1. Therefore, it means the power will be 2. The same applies to the next term in this case. We have negative 9x power 2. So we are saying this 2 will come and multiplies what? 9. So therefore, we shall have 18. Then we will have x be the power of x being reduced by 1. It means the power of x, you take away 1. It means therefore I will remain with x, because x raised to power 1 is simply x. I move to the next. We are here. In this case, the power of x is what? 1. It means that 1 multiplies 10. Therefore, I will have. Then I go back to the power of x. I reduce it by what? I reduce it by 1. It means therefore, the end result of the power of x will be 0. It means it will be now x raised to 0. And we all know that any number raised to 0 is 1. Therefore, in this case, in this term, I will end up with 10. I will not proceed to negative 3. Negative 3 is simply a constant. It is not having x next to it. Remember, it is a differentiation with respect to x. Since 3 is lacking x, therefore, I will ignore it. Then this will be the end result of my what? Differentiation. That becomes the end result of my differentiation. So having reached up to that point is when now we want to answer this concept, turning point. So the alternative meaning of this turning of the term turning point, it can be told stationary point. You can say stationary point. This is actually a point whereby if at all it was a particle moving, maybe a particle moving in air. So at that beat whereby it is turning, then it undergo resting. So in some point, in some particles or any other objects, for instance, when you throw a stone up, then it will rise until it reaches a point whereby it turns so that it comes back due to the forces of maybe gravity. It has to fall back. Then at that point whereby it rises, then it comes back. As it comes back at that turning point, it undergo momentarily rest. It undergo a rest. It undergo a rest that in real sense it cannot be seen by naked eye, but there is a stationary beat that it undergo when it is turning. So that is the point that we are concerned with. That is the point we are concerned with. So remember, when it is stationary, then we shall come at this point. Change in y all over change in x. When something is at stationary, it means it is not moving. Therefore, I will say dy dx at that particular point is 0. Stationary point, there is no movement. Therefore, dy dx is what? 0. So my expression of differentiation will now be equated to what? To 0. My expression now will be equated to 0. Therefore, I will have 6x squared minus 18x plus 10 is equals to what? 0. Is equals to 0. So what we have is basically a quadratic expression. This is quadratic expression. So this we can solve it with various methods that we all know about quadratic expressions. So let us maybe go by the quadratic formula. Let's go by the quadratic formula. So quadratic formula, it means then I will have, I'm finding x, that is minus b plus or minus b squared 4ac, everything all over 2a. I'm getting x, negative b. This is normally b, this is a, then that is c. b I have negative 8. In my formula I also have what? Negative b. So therefore, this negative and this negative will cancel and become positive. I will have 18 plus or minus b squared. It is negative 18 squared. So you will have negative 18 squared. That one gives you 324. I have negative 4a. A is what? 6. So negative 4 times 6, that is negative 24, times c, which is 10, that is negative 240. That is negative 240. Therefore, we proceed. 2a is what? 6. Then there it will be 12. So let's get x, that is 18 plus or minus. So that is 24, 324 minus 240. So here you will have 84. Not really, not 84. I mean, first of all, subtract what we have in the square root sign, that is 240. It gives you 84, then you get the square root of 84. So the square root of 84 is actually 9.16. Let me just round off, say 9.17. 9.17. Then it is all over 12. So as you can see, we are getting two values of x. So let's start when we are adding. So it means 18 plus 9, you divide by 12. What do you get? So your first answer will be 2.26. The next answer is gotten when I'm subtracting 18 minus what? 18 minus 9.17. What will you get? You will get 8.83 divided by 12. That one will give you 0.73. So these are the two values of x. Those are the two values of x. So the two values of x should give us their corresponding values of what? Of y. Remember, we are getting the what? The turning point. And a point comprises of x coordinate and y coordinate. So far we have gotten x coordinates. So we need to get their corresponding values of y coordinate. So y coordinate. We want to get y coordinate. So here we go. Y coordinate. When x is 2.26, what is the y coordinate? Remember, getting the y coordinate, I come back to my expression of y. Remember my expression of y. The expression of y originally is this. So where there is x, you replace with the value of x. That will be 2 into bracket 2.26 cube minus 9 into 2.26 squared, then 10 into 2.26, then minus 3. Let's see y. So y will give you 2 into bracket 2.26 cube minus 9 into bracket 2.26 t squared plus 10 into bracket 2.26 minus 3, and that gives you 3.28, that being the value of y when x is equals to 2.26. Sorry, it is negative. So it means that then our first point therefore will be 2.26 comma negative 3.28. This is the first turning point. Let's see the next turning point when x is 0. When x is 0.73. When x is 0.73. When x is 0.73. So it means when x is 0.73. So here will be 0.73, 0.73, 0.73. So let's see what the answer become. So let's see. We have 2 into bracket 0.73 cube minus 9 into bracket 0.73 is raised to 2 plus 10 into bracket 0.73 minus 3. What do you get? So here you get y to be equals to 0.28. So therefore, the next turning point when x is 0.73 will be 0.28. So these are our two turning points. We have this and this. So these two are our turning points. Turning points. Those are the turning points. So with those turning points, we want to know whether the turning points were at maximum or minimum or at a point of inflection. So this is what we do. This is what we do. This is what we do to know whether the points were at maximum, minimum, or point of inflection. Let's begin, or let's start with the first turning point as 2.26, negative 3.28. So determining the nature of the turning points, we normally draw a table. We draw a table of, let's say, how many columns? 1, 2, 3, 4. Or 4 columns. So that the first row here, row is when it is going horizontal wise. So the first row here will be the values of x. The next row will be change in y over change in x. It means it will be gradient. Then the next row I will be having diagrammatic representation. Diagrammatic representation. So let's start with the row of the values of x. Remember, the turning point we are concerned with is this. So normally, giving the values of x, we normally go back to the turning point that we are concerned with. In this case, it is this. So in this point, actually, there is coordinate of x coordinate. This x coordinate is normally put at the center here. You put it at the center there. Then getting the value here, we go for those values before this, before 2.26. Which value is actually before 2.26? Maybe in a number line. In a number line like this. If I have 0, then I can say I have 1, negative 1, going like that. Then I have 1, 2, then 3. So basically 2.26 is after 2. So the number before 2.26, I can simply put 2. That is the number close, and it is before 2.26. Then on the other side, on this box, you put a value which is close, and it is immediately after 2.26. It is immediately after 2.26. So I can put maybe 2.5 is ahead of 2.26. Or somebody can put 3. 3 is too far. You can simply work with what? 2.5. So let us now use the values of x as per how we have done them in the table. So we are going to fill the row of dy dx when we are having the values of x in that manner. So let's start with 2. What will be dy dx when the value of x is 2? Dy dx. What will be the value of dy dx when the value of x is what? Is 2. Means what will be the gradient when the value of x is 2?
This is a city on a hill, a school with God's glory. Education is light, my Kadzonzo, the only bright, shining star in the nation. Highly favored, my Kadzonzo, highly favored by God, so we are.